Welcome back with a new lesson 4.1 Approximate Numbers and Accuracy. Our objective for this lesson is to find the number of significant digits, which we call it accuracy, of a measurement. As we know, a measurement is the comparison of an observed quantity with a standard unit quantity. A measurement is only as good as the measuring instrument you use. An exact number is a number that has been determined as a result of counting, such as number of present students, 1, 2, 3, 4, and so on. So these are exact numbers. So we can say that only counting numbers are exact. All measurements are approximations. Only counting numbers are exact. All measurements are approximations. When we talk about accuracy of a measurement, we are talking about the number of significant digits that it contains. We learned about significant digits in lesson 1.11. To find number of significant digits in a measurement, we should apply these steps. First, all non-zero digits are significant. For example, in this measurement, all digits here are significant. So we can say here that we have 3 significant digits. So the accuracy for this measurement is 3. Also, all zeros between significant digits are significant. For example, if we have a measurement like this one, we can see that we have 2 zeros between 2 non-zero numbers. So these 2 zeros are also significant. So we can say that we have 4 significant digits in this measurement. Step 3. A zero in a whole number measurement that is specially tagged is a significant. Suppose that we have something like this. If we have a tagged 0, so we count from the left and we will count the tagged 0 with us. Since this number is significant and the tagged 0 is significant, the 0 between them is also significant because of step 2. So here we can say that we have 3 significant digits. Condition 4. All zeros to the right of a significant digit and a decimal point are significant. For example, if we have this measurement, we have 2 zeros to the right of a significant digit and a decimal point. So these 2 zeros are significant. So we can say that we have here 4 significant digits. Condition 5. Zeros to the right in a whole number measurement that are not tagged are not significant. For example, suppose that we have such a measurement. We have here 4 zeros to the right to a significant digit, but none of them is tagged. So none of them is significant because this is a whole number. We have no decimal point here. So we can say that we have only 2 significant digits. Condition 6. Zeros to the left in a decimal measurement that is less than 1 are not significant. So, for example, if we have a 0 to the left of a decimal point, suppose that we have this measurement, this 0 is not significant since this number is less than 1. So, we can say that we have 3 significant digits. Let us now take some examples on this. Look to this table. In the first column, I'll give you a measurement. In the second column, we try to find the accuracy, which is number of significant digits. Suppose that we have this measurement. What do you think about the number of significant digits in this measurement? We start from the left, counting from the first non-zero number. So we have 1, 2, 3, 4, 5, 6 significant digits. So we can say that we have accuracy 6 for this measurement. Another measurement. How many significant digits in this measurement? We start from the left, from the first non-zero number. So we start counting significant digits from here. 1, 2, 3. We don't count this 0 because it is not significant. We will not count these zeros because they are not between 2 significant digits. So the accuracy here is 3. A third example, 75 volts. I think this one is clear. All numbers here are significant. So we can say that we have accuracy 2. Example 4. In this example, we will start counting from the first non-zero number from the left. So we have 1, 2, 3, but this is a whole number. So we will not count these 3 zeros because they are not significant. We don't have a decimal point here. So it is accuracy 3 only. Example 5. In this example, it is the same like the one before, but we can see that we have a tagged 0, which is significant. So we will start counting from the first non-zero from the left, 1, 2, 3, and we will continue counting until we reach this tagged 0. So here we can say that we have an accuracy of 5 for this measurement. Example 6. In this example, we will start counting from the first number, which is not a 0, from the left. So we will start from here, 1, 2. But we will not stop counting because we have a decimal point, and these zeros are to the right of a significant digit and a decimal point. So we have an accuracy of 4. Now let us see this last example. In this example, also we will count from the left, from the first non-zero number. So we will start from this number 1, 2, 3, 4. This 0 is between two significant digits, and this 0 is after a decimal point. So we must count them all. So we have here an accuracy of 4 for this measurement. I hope by these examples that it is now clear for you how to find the number of significant digits in any measurement, which we call it in this lesson the accuracy. I hope we see you in another lesson later.